On March 3, 2024, Polish astronomer Kacper Wershaus was scanning images from the Mount Lemmon Observatory in Arizona when he spotted something faint moving against the background stars. 4 30-second exposures. Magnitude 20.4. Just another dim comet candidate. But as follow-up observations accumulated, something unusual emerged. This was not a typical comet looping back into the outer solar system for another orbit. Comet C-2024 Wershaus was arriving from the Oort cloud on a trajectory that would bring it close to the Sun exactly once and then send it outward permanently, not on another orbit. Out into interstellar space forever. This is not a visitor from another star system like Oumuamua or Comet Borisov. This comet formed here, in the same disk of gas and dust that made everything else in the solar system 4.5 billion years ago. It got scattered to the Oort cloud, sat there for eons, and is now passing through on its way out. After the gravitational kick from this solar flyby, it will eventually drift beyond the Sun's influence entirely and become, technically, an interstellar object. But it will not be arriving at someone else's system. It will be ours, leaving. The comet reached perihelion on January 2026, passing about 84 million kilometers from the Sun. On February 17, it made its closest approach to Earth at roughly 151 million kilometers, about the same distance as the Sun. That proximity, combined with its activity, made it visible through binoculars and small telescopes, though not to the naked eye. Observers reported a striking green glow in the coma, the diffuse cloud of gas surrounding the nucleus. That color comes from dicarbon molecules, C2, breaking down under solar ultraviolet radiation. It is the same green seen in a few other carbon-rich comets, but it remains rare enough to draw attention whenever it appears. What elevated this comet beyond a visual event was the fact that it was studied by the James Webb Space Telescope. In June 2024, Webb observed Weird-Tros from a distance of 7 astronomical units, about 1.05 billion kilometers from the Sun, and measured its spectra and dust production in infrared light. The results, published in monthly notices of the Royal Astronomical Society letters, revealed something specific. The comet was producing significant amounts of carbon dioxide, but showed no emission features for carbon monoxide. That matters. Carbon monoxide typically sublimates from comets at large distances, but Weird-Tros appeared to have lost its near-surface CO early in its evolution, likely before being ejected to the Oort cloud. The activity was being driven by CO2 instead, which sublimates at slightly warmer temperatures. That gives scientists clues about the comet's thermal history and how long it spent in cold storage before this passage. The distinction between what drives a comet's activity, water ice, carbon dioxide, carbon monoxide, is not academic. It shapes when and how the coma develops, how bright the comet becomes, and what we can infer about its formation conditions. Wershaus demonstrated CO2-driven activity earlier than water ice would allow, meaning it began outgassing while still relatively far from the Sun. By the time it reached perihelion and Earth's vicinity, it had developed multiple dust tails and an ion tail stretching more than 5 degrees across the sky, roughly the width of 3 fingers held at arm's length. Astrophotographers captured images showing the green coma alongside those extended tails, framed against deep space backgrounds including the distant spiral galaxy NGC 300. But the real story is the trajectory. The orbit is hyperbolic. That term has a precise meaning. An elliptical orbit is closed. The object remains gravitationally bound to the Sun and will return. A parabolic orbit sits at the boundary. Theoretically, the object escapes with zero excess velocity at infinite distance. A hyperbolic orbit is open. The object has more than enough energy to escape and will continue moving outward indefinitely. Weird-Tros has a hyperbolic orbit. The calculated eccentricity is greater than 1. That means this is a one-way trip. Importantly, the distinction between an extremely long-period elliptical orbit and a hyperbolic ejection trajectory can be subtle. Some sources initially calculated an inbound orbital period of millions of years, with an outbound period of around 200,000 years, noting that the energy difference between these scenarios is very small. But the confirmed classification is hyperbolic. The comet will not return. It will take decades, possibly centuries, for it to fully leave the Sun's gravitational influence, but it is not looping back. It is leaving the solar system. This raises a natural comparison. Interstellar visitors. Oumuamua, discovered in 2017, was the first confirmed object from another star system to pass through ours. Comet 2I Borisov followed in 2019. Just last year, Comet 3Wa Atlas made headlines as another interstellar interloper. Those objects arrived from outside, passed through, and left. Weird-Tros is different. It formed inside our solar system. likely in the region where the giant planets were forming. Gravitational interactions during the solar system's chaotic early history flung it outward to the Oort cloud, where it remained for billions of years. Now a perturbation, perhaps from a passing star or a distant galactic tide, nudged it back inward. This close pass by the Sun is altering its trajectory just enough to send it outward permanently. It will drift into the Milky Way, eventually traveling light years from the Sun, and may one day pass near another star entirely. If that happens, someone else's telescope might detect a faint green visitor falling toward them from the dark. That reflects a broader reality about planetary systems. They do not only receive wandering objects, they also eject them. Over billions of years, gravitational scattering sends countless comets outward. Some estimates suggest that for every interstellar object we detect passing through, our own solar system has ejected millions. Those objects are now drifting through the galaxy, fragments of our system's distant past scattered into the void. Weirschos is one of those fragments in the act of leaving. We are watching it happen in real time. The comet's nucleus is estimated to be between 2 and 10 kilometers in diameter, most likely on the smaller end of that range. Initial estimates based on brightness suggested a larger size, around 13.7 kilometers, but follow-up analysis of its CO2 production rate revised that downward. It is a relatively modest object, not a giant, but not tiny either. The fact that it has survived billions of years in the Oort cloud without significant alteration makes it scientifically valuable. These long-period comets are among the most pristine remnants of the early solar system, preserving materials that have remained largely frozen since the planets formed. As the comet continues outward, its activity will fade. The coma will dissipate. The tails will disappear. Eventually, it will become a cold, inert lump of ice and rock drifting through interstellar space at several kilometers per second. It will not be alone. Billions of similar objects are thought to be wandering between the stars, most of them undetectable unless they happen to pass close to a stellar system with telescopes capable of spotting them. This kind of event also reflects a shift happening in observational astronomy. The Vera Rubin Observatory, now beginning operations, is designed to detect transient and moving objects across the entire visible sky every few nights. That cadence will allow astronomers to identify comets earlier, track unusual trajectories more effectively, and catch hyperbolic visitors both inbound from other systems and outbound from ours, far more frequently than before. Veriscos may be part of a growing pattern rather than a rare exception. Better detection means more opportunities to study the exchange of material between stellar systems and to understand how often objects like this are scattered into deep space. For now, Comet Veriscos is fading from view. By early March 2026, it will have dimmed beyond the reach of most amateur telescopes, but its trajectory is set outward, away, into the galaxy. A 4.5 billion-year-old piece of the solar system's formation, leaving home for good.